Hey everyone, welcome back to TechBit Academy. Please like this video and subscribe to the channel.
Welcome to this explainer. We've all been there. You pick up one gadget and it just works. It feels completely effortless, like it's reading your mind. But then you try to use another device, and within 30 seconds, you're literally ready to throw it out the nearest window. So what's actually going on there? Today, we're diving into the hard science behind why some tech is so insanely frustrating and how brilliant design transforms that frustration into seamless function. Okay, let's dive into this by tapping into a universal shared trauma. If you are around in the cassette era, you know exactly what I'm talking about. The endlessly flashing 12 o'clock on a household VCR. Millions of people literally just gave up and accepted that their clocks would blink forever. But really think about that for a second. Why was a machine built strictly for living room entertainment so notoriously impossible to program? Well, the answer comes down to a compounding series of design failures. We're talking about fatal flaws like hidden state, mode confusion, poor mapping, inadequate feedback, and complicated configuration. Honestly, any one of these is annoying on its own, but stacked together on a single box, it creates an absolute interface disaster that perfectly illustrates a massive failure of human-centered design. Let's break down exactly what went wrong here. First up, we've got the hidden state. Imagine standing in front of your VCR. Is it ready for a command? Is it silently rewinding a tape in the background? Is it paused? The machine simply didn't show its actual state clearly. Because of that lack of visible readiness, you were forced to basically just push buttons and hope for the best. And as you can probably guess, guessing almost always leads to errors and utter chaos. Then we have mode confusion, which is, quite frankly, maddening. VCRs were highly modal devices. That means pressing the play button did completely different things depending on unseen modes. If the device was secretly stuck in timer programming mode, pressing play might do absolutely nothing, or it might trigger some weird unexpected menu. Because you couldn't see the mode, your intuition was completely shattered. You formed a bad mental model of how the machine worked, and the machine punished you for it. Couple that with poor mapping. Think about the physical controls, obscure squares, double bars, triangles, and those deeply buried menus for scheduling. Those symbols just did not match the real-world logic of an everyday user. The way the engineers mapped the controls to the actual functions completely ignored how a novice actually thinks about, say, just recording a TV show. And let's say you miraculously press the right sequence of buttons. You immediately hit the wall of inadequate feedback. You press a button and what happens? Maybe a tiny, ambiguous red light flashes. Was that a success? A warning? Did it even register my push? It left users completely stranded, wondering if their action even worked, which is exactly why people would jab the same button 5 more times, just to be sure. Now, what's really interesting here is how this concept summarizes the ultimate pain point. Users must translate real-world goals into obscure sequences of button presses, and often fail. Think about a super simple goal. I want to record Channel 4 on Tuesday at 8 p.m. That makes perfect sense to a human. But the VCR forced you to translate that natural goal into a complex, alien sequence of button pushes. It was a translation nightmare, and the human almost always lost. And this brilliantly illustrates the dividing line between two completely different ways of building things: traditional software engineering versus usability engineering. Traditional engineering focuses almost entirely on technical functionality, making sure the gears turn and the code runs, and users are just brought in at the very end. But usability engineering flips that entire script. It zeroes in on usability metrics and demands early, continuous user involvement. It is the direct contrast between just making a machine work and making it work for humans. So let's officially introduce the hero of our explainer today: usability engineering. It's defined as a systematic, structured approach to designing interactive systems that are usable, integrating these activities throughout the entire development lifecycle. Now, the absolute keywords here are systematic and structured. User-friendliness is not a happy accident. It's not an afterthought sprinkled on at the end. It is a rigorous, measurable engineering process. So the crucial point is, how do we actually pull this off? How do we guarantee we never build another blinking VCR? Well, we do it by locking in on the 4 key elements of usability engineering. This is the micro-narrative of how we actually fix the nightmare of bad interfaces. Here's the roadmap. These 4 logical steps: usability specification, user-centered design, iterative design, and evaluation and testing show exactly how usability gets engineered into a product's lifecycle from the very first brainstorming session all the way to launch. Let's walk through them. It all kicks off with step 1, Usability Specification. Listen, long before a single line of code gets written or a prototype is built, engineers have to set formal, measurable goals. You can't just wave your hands and say, hey, let's make it easy to use, because easy is totally subjective. You need concrete data. So what do those measurable goals actually look like? They track super specific metrics. Task completion time, literally, how fast can someone actually schedule a recording? Error rates, how many mistakes do they make along the way? Learnability criteria, how fast can a total beginner figure the system out? And of course, user satisfaction levels. By defining these metrics up front, you swap out developer assumptions for cold, hard facts. It gives you concrete proof of whether a system is actually usable. Once those goals are set, we move to step 2, user-centered design. This is where the process demands that your design has to be completely grounded in the reality of the human being who's actually going to use the device. You have to take the engineer out of the pristine lab and put them into the messy real world. This step focuses on 3 major areas: truly understanding the users, understanding the specific tasks they're trying to accomplish, and understanding their environment and context. Are they using the device in a dark living room? Are they distracted? By deeply tracking real user behavior in their natural habitats, engineers can finally avoid those buried menu problems of the past. They design for the real world, not an ideal scenario. Let's move to and see how this builds into our 3rd pillar, Iterative Design. Now, this is a massive departure from old-school, traditional manufacturing. The absolute core concept here is that design is not linear. It is not a straight road from point A to point B. Instead, it's a continuous loop. Systems are designed, they are tested, they're redesigned based on those tests, and then they are tested all over again. Why do this? Because identifying a problem early in the cycle makes it exponentially cheaper and easier to fix. Believe me, you don't want to find out your main menu is broken after you've already manufactured 1 million units. Which brings us to the final pillar, step 4, evaluation and testing. In usability engineering, evaluation isn't just some final exam you cram for at the very end of the semester. It's a constant, ongoing detective process that runs through the entire life cycle. Engineers use really specific techniques here, things like formal usability testing, directly observing users as they struggle through tasks, and actively measuring their performance against those baseline error rates we set way back in step 1. By directly observing exactly where people stumble, it creates this undeniable feedback loop that drives ongoing design improvements. The user's struggles literally become the engineer's blueprint for a better product. So, what is the core takeaway of this explainer? Usability has to be engineered, period. It requires explicit goals, early and continuous user involvement, and relentless evaluation. Truly great design, the kind that feels effortless and magical, is never an accident. It is a highly intentional, rigorous engineering discipline driven entirely by human needs. And I want to leave you with a slightly provocative thought to ponder today. Take a look around your house right now. Think about your smart thermostat, your connected fridge, or those automated lighting systems. Ask yourself, are our modern smart home devices just repeating the sins of the VCR? Are they hiding their state? Are their modes confusing? As you interact with technology this week, keep these usability principles in mind, and you might just realize exactly why that smart speaker is driving you absolutely crazy. Thanks for joining me on this explainer, and always keep questioning the design of the world around you.